Good day. This presentation is entitled Quantifying the Shift in Network Usage Upon Bandwidth Upgrade, and it's a collaborative effort between myself, Joshua Okuthe, and Professor Alfredo Tassoli. The network bandwidth utilization at the Assumption Development Center was at its maximum capacity of 1 megabits per second during peak traffic, and therefore we wanted to find a solution to this problem, and we embarked on traffic classification with the aim of determining which applications were contributing to the congestion, and secondly, whether the applications were legitimate, and lastly, if upgrading the bandwidth would be required and whether that will ensure acceptable user experience. The topology of the ADC network as follows. There's a base station at Monument Hill and 1 gigabits per second backhaul to Rhodes University Data Center, and the local loop is a 1 megabits per second Wi-Fi link, and within the Assumption Development Center we got a gateway router, which is a MacroTik 750 router board, and connected to a switch, and the switch links to the lab, which is shown here, and there's also an access point connected to the switch, which provides connectivity to wireless endpoints. Now, because we realized that all traffic was legitimate, and so to ensure the user experience is maintained, the local loop was upgraded to a 10 megabits per second Wi-Fi link. The traffic was captured at 2 points. The first point was at the gateway router interface, and the second point was at the mirror port on the local LAN switch. And the baseline data was collected before the upgrade, and then a second set of data was collected immediately after the upgrade, and the last set of data was collected 1 month after the upgrade. And the data was analyzed using NTOP deep packet inspection, which was installed on the laptop. For offline analysis, the packets were dumped into a pickup file, and the baseline data collection occurred in June, July, and August 2019. Nonetheless, we selected a sample from a 3-week period in August 2019 for analysis. And the second set of data was collected in February 2021, immediately after the upgrade. And the third data collection took place in March 2021, 1 month after the upgrade. The results show that before the upgrade, the maximum incoming traffic was 1 megabits per second, which is the maximum capacity of the local loop. And immediately after the upgrade, the traffic, maximum incoming traffic increased to 8.13 megabits per second, as depicted in figure 5. 1 month after the upgrade, there was another increase in inbound traffic by 15%, from 8.13 megabits per second to 9.57 megabits per second. And that is shown in figure 6. We can visualize the increase in network traffic in week 7 of 2021, and the reason for that was the upgrade which took place the last day of week 6. There was a weekend in between, and immediately after that we see an increase in traffic. In terms of traffic distribution before the upgrade, we see that most of the traffic was web-based, 91.63%. There was a small proportion of DNS traffic. Immediately after the bandwidth upgrade, we can see now the DNS component increased to 45.28%. The web component is still slightly higher at 49.42%. 1 month after the upgrade, we see now the DNS component is at 56.14%, which is now higher than the web proportion, which is 43.26%. You can visualize the comparative view of the traffic. Before upgrade, you can see that the web components is quite high. Immediately after the upgrade, you can see that the web component is slightly higher than the DNS component. And 1 month after the upgrade, you can see now the web component is lower than the DNS portion. Analysis of the LAN traffic from the switch meter port shows that the local traffic is much higher than the traffic through the gateway router. The LAN traffic is 22.55 gigabits, and over the same period, we're talking about the 3 weeks immediately after the upgrade, you can see that the internet traffic, the traffic through the gateway router was 669.24 megabytes. We can also drill down the traffic and determine the different type of applications. And from here we can see secure socket layer having the highest proportion, followed by Google and Apple. So you can see here secure socket layer, and then Google, and then Apple. So the others, the proportion from the other application is lower than those three. You can also see the emergence of applications like YouTube and Windows update. You can see those ones here. Sorry. Before the upgrade, the network was congested during peak times, and there was significant loss and delay, particularly during the peak periods. The maximum portion of the traffic was web-based at 91.63%. And because the applications were all legitimate, a decision was made to upgrade the network bandwidth from 1 megabits per second to 10 megabits per second. And that led to an improvement in user experience, and also the emergence of high bandwidth consuming applications. We also saw an increase in the DNS traffic component. 1 month after the upgrade, we saw that there was an increase of 15% on the maximum inbound traffic, and there was also an increase in the DNS proportion of the traffic. We also saw that there was a significant difference between the internet traffic and the LAN traffic volumes for the same period. That was immediately after the network bandwidth upgrade. This could be due to traffic localization as a result of web caching. And web caching service is currently provided by the web server, which also provides DHCP and DNS services. And we think if we can relocate the the caching and DNS services to the gateway router. That would improve performance. The upgraded bandwidth appears to be quickly approaching saturation point. So management of network usage is therefore crucial. And because applications are all legitimate, blocking certain applications is not a viable option. And so what we need to do, apart from to manage the network usage, is also to make sure that we reduce the web and DNS traffic components. And that is a project that we have undertaken, and we continue to do so. It's an ongoing project. The aim would be to ensure that 20% gap exists between the maximum inbound traffic and network capacity, in order to ensure that user experience is not adversely affected. We wish to acknowledge the support from Telkom SA and Infinera SA. We are grateful for their support, which enabled successful completion of this project. Thank you.